Welcome to PE Academy. So in this video, we are going to be looking at electric field intensity due to 2 points charge. So in the previous part, we looked at electric field intensity, but now we are looking at it from the perspective of, okay, if there are 2 points charge acting, if there are two charges acting on a particular point, and you're asked to calculate or find the electric field intensity. All right, so now let's look at what we have here. It says electric field intensity due to 2 points charge Q1. So let's say this is the first charge Q1 at R1. And Q2 at R2 is the sum of the forces on QT caused by Q1 and QT acting alone. All right, so what this is saying is that if you are to look for the electric field intensity due to 2 points, it's just the sum of the electric field intensity, or should I say the sum of the forces that is acting on that particular point by the independent charge. All right, so let's do some writing now. So if we have a particular point, let's call this point point P, and then we have two other charges, Q1 and Q2. So let's say our Q1 is somewhere here, and then our Q2, let's place our Q2 here, and then these charges Q1 and Q2 are acting on this point P. Exactly. So this is Q1, this is Q2. So definitely the coordinates for this Q2, let's call that as what is the R2 is representing, and then this is for R1. Okay, so if we are to look for the electric field intensity at this point P, so that is going to be the electric field intensity of Q1 plus that of Q2. Exactly, so that's going to be the electric field intensity of Q1 and that of Q2. That will give us the electric field intensity. So let me just capital at point P. So to write that down, so that means we are going to be having to calculate the electric field intensity due to Q. So that is going to be Q1 over 4 pi E naught. So multiply, because we are looking at it in vector form. Exactly. So we are going to be having, okay, E naught, then R square multiplied by the unit vector. Let's call that R, let's just call that R1 over the magnitude of the unit vector. So let me put this over the magnitude of the unit vector, so without the square, plus Q2 over 4 pi E naught, and then the magnitude square, let me call that R2, so multiply by the unit vector, so let me call that R2 over its magnitude. Okay, so that is how you are going to go ahead to calculate the electric field intensity between 2 point charge. So if there are more than two charges, so for example in this now we're having two, so if there are more than two charges, maybe 2, 3 or 4, so it's just the same process you are going to use. So it's going to be, let's say it's more than 2 for instance now, maybe you are dealing with more than 2, so that means E is equals to Q1 over 4 pi E naught, then the square of the unit vector, so let's just call let's represent it with 1 square, then multiply by the unit vector by its magnitude, so then plus the second charge Q2 over 4 pi E naught, so the square of the magnitude of the unit vector multiplied by the unit vector over its magnitude, so plus, so you continue like that. This will be Q3, so let's just say Qn over 4 pi E naught. Okay, so this should be 2. This should be 2, 2, 2. So over Rn square multiplied by the unit vector over its magnitude. Okay, so that is it on the field intensity between 2 points charge. Then the unit will still be the same like the other part of the video where I talked about the unit. So the unit is still Newton per coulombs, or you just use V over M. So that's the unit for electric field intensity. All right, so that is it. And the next part we're going to be looking at a typical example on, especially when you're having more than 2 points charge. That's the most common one. So that's just the most common one, between maybe 3-4 points charge. So how do you go ahead to calculate it? So that's what we're going to be looking at in the next video. So if you're yet to subscribe, kindly click on that subscribe button to subscribe so that you can get notified as soon as that video is out. And if you're watching this video much later, you just find the link to the video on that playlist on Electromag. Alright, so thank you very much, and I'll see you all in the next one.